Okay, this is going to be over section 5.2, applications of Newton's second law. So when the vector sum of the forces on an object is not zero, the object has an acceleration determined by Newton's second law. The sum of all of the forces is going to be equal to the mass times the acceleration. So in component form, if we look in the x direction, the sum of all the forces in the x direction is going to be equal to mass times the acceleration in the x direction. Same thing holds true for y. So again, if we take a look at our block, we've got a normal force, we've got tension, we've got the weight, and we have an acceleration in this direction. Well, again, if we look at the breakout of the forces here, we've got the weight times the cosine of alpha and the weight times the sine of alpha, normal force, and the weight times the cosine of alpha. You're not seeing any force in that direction, so the sum of those forces is zero. However, when you look at the sum of the tension force and the sum of the weight that is pulling in the x direction, you actually do end up with more force in one direction than the other. And that's why you have the sum of the forces in the x direction is equal to mass times the acceleration in the x direction. So that's why sometimes drawing a free body diagram can sort of show you what's going on. If we go and we actually look at the section itself, there's going to be a number of problems here that I want you to work through and to kind of see if you get the concept of Newton's second law. So you've got several of these down here. Again, they're in your access package. So please do go through them. I'm trying to keep the number of lectures here short. So as you go through, if you do have questions, there are some tutorials that go along with this, so just bear that in mind.